Now let us see how the timing diagram works for this kind of circuit. So first of all, so here I'll be getting count since we are designing for decade counter. Okay, now output of A, that is QA, and depending on which we will see QD, QC and QB. Okay, so initially they all are reset to 0 0 0 0 and the count is also 0. QA, QB, QC, QD. Okay, where QD is being as the MSB part and A is as LSB part. Since we know that the clock is connected to input A, so QA is going to change for each falling edge. So for first falling edge, QA will change to 1, then it will go to 0, again it will go to 1, 0, same way it will follow. But we know that the output of QA, that is as clock to the divide by 5 counter connected to pin number B, so this will change whenever the A is falling from 1 to 0. So in the first case, A is rising from 0 to 1, so this 0 0 0 will remain as it is, and for 1 to 0, that is A is falling, so for falling edge of A, QB, QC, QD will change its states to increment by 1. So this will be 0 is incremented by 1 first trigger, so 0 will move to 1. Since this is divided by 5 counter, so it will go from 0 1 2 3 4, and after 4 again it will go to 0. Okay, since A is rising, it will not change. From A 1 to 0 it will change, so this is 0 0 1 2 times. After that it will move to 0 1 0, so it will move to 0 1 0 0 1 0. Okay, and A is moving from 0 to 1. Once again, when A moves from 1 to 0, it will change to 0 1 1 0 1 1 when A moves from 0 to 1. Next time when A moves from 1 to 0, that is the falling edge of A, again it will change it to 1 0 0 1 0 0. Okay, so now if you see the counter states QD, QC, QB, QA, it is going from 0 to 1, count 0 1 2, it is 3 4 0 1 0 1 5 0 1 1 0 6 0 1 1 7 8 and 9, and hence the count is complete. What will happen after this? If A will try to go to 0, that is nothing but falling edge of A, this will be incremented. So this is position 0, position 1, position 2, position 3 and position 4 for the mod 5 divided by, this is the divided by 5 counter output. So after 4 it has to return to 0, it will go to 0 0 0, and hence the decade counter is obtained with the help of IC 7490. You can also get a divide by 10 counter if you will put the input to B, this clock input. If this clock input is connected to B, okay, then it will go first to the divide by 5 counter. So this block diagram, let me modify it for you. Okay, so this clock will be going first to divide by 5 counter, then the first output you will get here QB, QC and QD part. Okay, and what are the output QD coming, which will give to A as the input, so it will go to input clock for A, which is nothing but divide by 2 counter will give you output QA, and all the pins, that is nothing but pin number 2 3 6 7 and 10, these are all shorted to ground to make 7490 in the counting mode. So this total circuit will be a divide by 10 counter. Okay, apart from this circuit, you can give the input to B, and the output of QD, that is the divide by 5 counter output, can be given as trigger to input A, which is divide by 2 counter, and from 1100 you can go to 1001, that is 9, you can go to 0, that is nothing but divided by 10 counter. So that's all about the 7490 as a ticket counter. Internally it is divided into divide by 5 and divide by 2 counters, and you can use it for mod 10 counter or the divide by 10 counter. So that's all about the IG7490, and thank you for watching in 5 minutes, and stay tuned.